Hi, Assalamualaikum warahmatullahi wabarakatuh and very good morning. Today we're gonna present to you guys one of the topic in calculus 1, which is related rates. First of all, I'm gonna introduce you guys to the group members. First of all, you got me, Muhammad Amruddin bin Muhammad Azhari. I will handle in introduction. Next, you will have Muhammad Muaz bin Masdukin. He will handle in first question. Last but not least, you got Muhammad Haris Farhan bin Hussein. He will teach and explain about the last question. What is related rates? Related rates is rate of change associated with two or more related quantities that are changing over time. The rate of change is usually with respect to time. You guys may ask what to solve, right? Usually the question will ask for the final volume. It could be an increasing or decreasing volume. You could see at the slide, the signal is increasing due to the time. At the time 1 is lesser than time 2 because the volume is increasing. Same goes to the balloon. We could see the time 1 the volume of the balloon is lesser than time 2 because of the volume is increasing respect to the time.
Question 1 is how to solve the problem. Show that a metal cube with expanding uniformly as a heat at a time t second. The length of each edge of the cube is 8 cm and the volume of the cube is vcm cube. Question to how to solve this problem is show that dv per dx equal to 3x square. From this equation, we know that the volume is x times x multiply x equal to x cube. Then differentiate that we can exactly 3x square. We can get cx square. Equation is given the volume vcm cube. The increase at a constant rate of the 0.048 cm cube per second. Question is find dx per dt when x equal to 8. So the question 2 is dx per dt equal to dx per dv multiply dv per dt, and we can substitute the dx is changed to x. We can change the 1 per dx square time 0.048, and we can substitute the s equal to 8, then we can exactly get an answer 1 per 4000 cm per second. Lastly, equation 3 is find the rate of increase of the total surface area of the cube in cm cube per second when x equal to 8. The equation is we must know to find the surface area for cube equal to cx square cx cube, and we can differentiate that dA per dx equal to 12x, and we know that dA per dt equal to dA per dx multiply dx per dt, and we can substitute 12x times 1 per 4000, and x substitute 8, and 12 times 8 12 multiply 8 multiply 1 per 4000, and exactly we can get the answer 0.024 cm cube per second.
Okay, now let's proceed with the second example for today. Okay, from the question, we know that volume is equal to 3h square plus 4 in the bracket to the power of 3 over 2 minus 8. And h is equal to the depth of liquid. The first part of the question, we need to find the volume of dV over dH. And it is given that h is equal to 0.6. dV over dH is calculated by dV over du times with du over dH, because we need to use chain rule in order to differentiate the volume. We let u equal to 3h square plus 4, and then du over dH is equal to 6h. V will become u 3 over 2 minus 8, and differentiate that to become 3 over 2 u to the power of 1 over 2 minus 8. We put them all together to get 3 over 2 times with 3h square plus 4 in the bracket to the power of 1 over 2 times 6h. Then we substitute the given h, which is 0.6, into the equation and get 12.17 meters square. The second part of the question, it is given that the rates of decreasing of the depth of liquid is 0.015 meter per hour. So since the decreasing rate, we must put negative in front. Then we need to find the dV over dt, which is the rates of decreasing volume per hour. To answer that, we must find dV over dt, which is equal to dV over dH times dH over dt. dV over dH we get from the first part of the example, which is 12.17 times with negative 0.015, which is given, and we will get negative 0.1826 meters square per hour. We conclude our topic for today with application of related rate in real life. Related rates allow us to calculate the theoretical longevity of a product to save cost and energy usage in research. Engineers often encounter problems that involve finding a rate at which a quantity is changing by relating it to other quantities whose rates of change are known. Lastly, big thanks to you guys for watching this video, and have a good day.